Euler's theorem. Read Euler. He was the master of us all. A and N are. So when we work mod N, technically we're establishing a relationship between two things. I'll say more about that in a minute once you've had a chance to look at this. It means if you say that A is congruent to B, mod N is that N divides A minus B. And it's not required that like if N divides A minus B, it also divides B minus A. So you can talk about divisibility of a negative number. That's not an issue. So for instance, 7 is congruent to 1 mod 3 because 3 divides 7 minus 1. Now what this technically is from the pure mathematical perspective is this is a relationship between pairs of numbers. So I have all of these things, and if there's multiple of 3 apart in the same equivalence class. So 1 is congruent to 7, 7 is congruent to 4 mod 3. You can also go backwards. So -2 is congruent to 4 mod 3. Do y'all see what I'm doing here? So then what would -1 be equivalent to mod 3? 2 and what else? 5 and 8. And then what would 0 be congruent to mod 3? 3 and 6 and 9. These are partitions. You can partition these into 3 sets. So you have, and what people do is they write these square to indicate this is the thing that 0 lives in. What they really mean is that they're looking at all of the numbers that are congruent to 0 modulo 3. So that's the notation some people use with the square brackets and the 3. So if you look at it that way, how many different equivalence classes do you have? You only have 3 equivalence classes. You're either in the white square, the white circle, the blue circle. So 1 would be the set of these things that include 1, 4, 7, 10, 13, everything that has a remainder of 1. And then the equivalence class represented by 2 would include all of the things that have a remainder of 2 when divided by 3, or equivalently, or you can think of their difference with 2 as divisible by 3. Those are equivalent. So this equivalence class idea is related to another idea that we've seen previously that was really close partition. This is a partition of the integers because it's 3 separate sets. And if you pick any one of those sets, if you pick any element, it's in exactly one of these sets. So this is a partition of the integers as well into 3 equivalence classes. Now, many mathematicians, and they have good reason to be, are very, very precise about the square bracket defining this set. They want to emphasize that they could have done this a different way, that they could have chosen 3 to be the representative, and that would have defined exactly the same set, because this is saying all of the things are equivalent to 3 mod 3. And here they could have chosen 4 to be the representative, or they could have chosen 7 to be the representative. Do you follow me? So all of these things are equivalent. So all of these things are equivalent. Often when people do this in the real world, they don't care about the other representatives. They only care about the smallest. Their goal is to reduce it down to just a number between 0 and the modulus -1. If you see computer scientists and cryptographers, they often, instead of thinking about it this way, will think about it this way. The function where you're taking the remainder after you divide by it. Yeah. And that's a different way of thinking about it. You're no longer thinking about it as a relationship where you're saying these two things are related to each other. Instead, you're saying, I'm going to come out with a number, and that's the answer. Does that make sense? For instance, they would say 7 mod 3 is equal to 1. Their goal is to actually reduce this and come up with a single number, not to think of it as a class of numbers. Do you understand that distinction? Unfortunately, the exact same terminology and notation is used for both. The computer scientist Donald Knuth proposed that we use lowercase mod for one and uppercase mod for another because it causes so much confusion with the fact that these are overloaded in terms of their notation. The big thing you need to know is you need to be aware of the context you're working in, how important it is to think about it in the way that you're thinking about it.